Hello students, we are discussing chapter sets. So far we discussed the operations on sets like union operations on sets, intersection operation on sets, difference of two sets, and last class we discussed complement of a set. And while finding the complement of a set, if suppose this set A is given, we can show it in Venn diagram like this. Complement of set A. This is our universal set. If A is a subset of U, then complement of set A are those elements which present in the universal set but not in set A. So let us shade the portion, the elements which are present in U set, universal set but not in set A. So this shaded portion is our A complement. Already we discussed this. Shaded portion is our A complement. Also, basing upon this, one note is here. You can find from Venn diagram that if A is a subset of U, then A complement is also a subset of U. See, A is a subset of U, we have taken A complement, the shaded portion is also a subset of U. So this you can prove from the Venn diagram, and here it is shown. Similarly, another remark is complement of A complement is nothing but the set A itself. See from the Venn diagram, this is our A complement, this shaded portion is our A complement. Its complement again means excluding the shaded portion. Which set is the set A itself? So complement of A complement of a set is that set itself. Based upon this complement, let us solve an example. Suppose our universal set is, let set U is our elements 1, 2, 3 up to 10, and set A containing the elements 1, 3, 5, 7, 9. So what is our A complement? A complement is those elements of U which are not present in A, means excluding the elements of A, rest elements of U are the A complement. So what are the elements of U which are not present in A? Those are 2, 4, 6, 8, 10. So this is our A complement. Similarly, you can find if universal set is given and any set is given, then complement of that set you can find. Now some properties on complement. Properties of complement sets. First property is set A union its complement. What will be this? From the Venn diagram what we drawn previously, you can find that a given set and its complement, if you will find the union, you will get the universal set. From that Venn diagram you can find that or show that. Similarly, also you can see from the Venn diagram that if you are finding a set intersection A complement, that is nothing but your phi set. Complement of a set and that set intersection, there is no common element. So these two properties are called complement law. Then third property based on complement is the one of the important law, that is De Morgan law. De Morgan's law. Based on the complement, first one is A union B complement is equal to A complement intersection B complement. Means complement of union of two sets is the intersection of their complements. This is the first De Morgan law. Another is, if we will find intersection, complement of intersection of two sets, this is A complement union B complement. That means, in other words, you can say complement of intersection of two sets is the union of their complements. This you can prove using Venn diagram. Yes, let us first prove this first property using Venn diagram. A union B complement. So your LHS is A union B complement. You show this in Venn diagram. This is our universal set. A is a subset of U, B is a subset of U. You know A union B is the set of all the elements of either A or in B, or which is common to A and B, that you know. So A union B is your this set is your A union B, but here A union B complement. So which elements are the present in U but not in A union B. So let us set the portion of A union B complement. So our shaded portion is A union B complement. Now your right hand side, we are proving first bit. This first bit, left hand side this one, and right hand side. Right hand side is A complement intersection B complement. Let us show this in Venn diagram. A complement. A complement is nothing but the elements present in U but not in A. So excluding all those elements of A, let us set the portion. You see here, excluding the elements of set A, rest elements are your A complement. Now B complement find out. B complement means excluding the elements of B, rest elements. Let us say it in another way so that there will be no confusion. Yes, excluding the elements of B, rest elements are your B complement. Now what is the common? A, because here intersection, you know, intersection of two set is the elements common to both set, that is A complement intersection B complement is this portion which are double shaded. So your double shaded part, this part, see here, double shaded portion is your A complement intersection B complement. So now you see, in this case double shaded part is your A complement intersection B complement, and in this case the shaded portion is A union B complement. In both cases you see the shaded portions are same. Therefore in this way, means using Venn diagram, we proved the first law of De Morgan, that is A union B complement, it is equal to A complement intersection B complement. Similarly, using Venn diagram, you try to prove the second part of De Morgan law, that is complement of intersection of two sets, it is equal to union of their complements. Try to prove. Then, based on complement, our third law is law of double complement. So, what is that law? That law is A complement of A complement is the set A itself, that is called law of double complement. And next is law of empty set, that is complement of phi set, it is your universal set. You try to prove using Venn diagram. Another is law of universal set, that is U complement, it is phi. Law of empty set, that is phi complement, that is universal set, and U complement, that is equal to empty set, which is called law of universal set. You can prove this using Venn diagram. Thank you.